Okay. I'm just going to kind of start back from the beginning. We'll do a little bit of review. We'll prove some of the angle, side stuff that we talked about yesterday. We'll also prove the HL, and we'll look at a couple of examples as well. So, again, we should have taken notes on this yesterday. If not, I can put that up later. Just let me know. All right. We saw angle, side, another triangle congruence. If you got two angles and a non-included side, again, that's enough to show that your triangles are congruent. So let's take a second and prove that. Oh, we already saw that too. All right, let's prove the angle, side, triangle congruence theorem. So hopefully you left some space underneath that definition. Go ahead and set up statements and reasoning. And maybe give yourself two triangles. I've got two triangles here. Triangle ABC. I got triangle XYZ. And I'm going to go statements right underneath here. And I'll squeeze in reasoning. All right, so take a second, get something set up in your notes so we can go ahead and prove this. Again, maybe a little picture. And here there isn't anything like in words that's telling us what we know, but we could probably, figure that out from context, from the picture, knowing what we want to prove. I mean, what do we want to prove? What should be our end goal if we were using the angle, side theorem? Yeah, if we're using this theorem here, I'll just put it back up real quick. If you actually read through that, it says that if, that's kind of like your given part, right? If two angles and a non-included side between both these triangles, then the triangles are congruent. So that kind of gives us our given and what we want to prove. So now we kind of, we have a plan going. All right. We're good. Ready to go. You guys look so excited. So excited. Okay. Step one, what's something we know? Even from the picture, maybe. There we go. Angle B and angle Y, right? Angle B congruent to angle Y. Thank you, David. I mean, it's angle, side, so we got to find another pair of sides and another pair of angles, right? Yep, X and A. Oh my goodness. How about segment AC? Segment AC congruent to segment XZ. Kind of rhymes. Okay, and that we could just put underneath, whoops, given. And now here's kind of the trick. If we're trying to prove angle side, we can't use it in the proof, right? You can't use it in the proof if you're trying to prove that it's true. So we're going to have to use something else. Maybe side, maybe angle, side, angle, right? We're going to have to use something else in order to get that step where we see our triangles are congruent. So can we say anything about another pair of sides? I mean, Samantha's shaking her head. Yeah, it's not a right triangle, right? So we can't even use Pythagorean theorem here. What about another pair of angles? What about angle Z and angle C? Anna Karen says those two. Yeah. Does anyone know the reasoning why we can say angle C and angle Z are congruent? What was that? That kind of deals with, alternate interior deals with like parallel lines, right? And they're not vertical angles. They are a third pair. Do you guys remember the third angles theorem? A little bit, that said that the third pair of angles kind of comes along for free if you already have one pair. You have a second pair. By the third angles theorem, we can say that this last pair has to be congruent, right? Third angles theorem. And I'll even go mark it in the picture, right? I'll just go add 3 of those little arcs. Thumbs up, thumbs down. Are we good so far? We're hanging in there? Okay. Let's think about a step 3. Well, we just said another pair of angles, and if, again, we can't use angle side here, but what other triangle congruence could we use? I'm going to take out those angles there. What does that look like? Angle, side, angle, right? I mean, we found that third angle. Now we could use angle, side, angle. We've already written that down. We already have that in our notes, right? That's something that's true. So step 3, well, now we can say that triangle ABC is congruent to triangle XYZ. Again, we're using a different triangle congruence theorem. We're using ASA to prove another, right? There we go. Check mark, good to go. Joanne, thank you. Yep, ASA. You guys are rocking it. All right. Good proof to start the morning. Let's look at another one. Okay, let's see. Let's do that one at the end. We talked about also parts of a right triangle yesterday, right? This should be, again, review, leg, and hypotenuse. And that's kind of what leads us to the theorem HL. Okay. And I'll put that up at the end of class if you haven't got that. Just remind me, since most of us already wrote it down yesterday. Again, HL, let's say you've got a leg, if this was a right triangle here. You've got a leg congruent and you have a pair of your hypotenuses, then again, that's a little shortcut. So let's take a look and prove this. So we're going to do it kind of as an informal proof. All right, so you don't need statements and reasoning because we're just going to kind of walk through it together. So hopefully you have some sort of picture here somewhere in your notes from yesterday. Maybe you want to say, you know, this is a proof of hypotenuse leg. And again, we can see we have segment AC and segment XZ being congruent. We have AB, that hypotenuse, and XY being congruent. Again, if we are trying to prove HL, we can't just use HL here and say, all right, done, good to go. And also I want you to notice that I'm using these other smaller letters here to represent the side length, the actual length of the segment, because I don't want to have to write segment AB, because we're going to use the Pythagorean theorem here. I don't want to have to write AB squared, so I'm just going to say C squared for AB. All right. Okay. So I said we were going to have to use the Pythagorean theorem. What was that again? A squared plus B squared equals C squared, right? That said that your leg squared plus your leg squared equals your hypotenuse squared, and I have that right here, right? A squared plus B squared equals C squared. So I'm just going to start by writing that. That's something I know. It's a right triangle. I should be able to write that equation. So let's just start with that. Let's say, and if I was doing a statements and reasoning, I'd say, you know, this was just by the Pythagorean theorem because it's a right triangle. Now, if I had to use the Pythagorean theorem with this triangle, what kind of equation would you write? And that's an X. Sorry, and that's a Y, and that's a Z. We just want to set up another equation, kind of like this, but for this triangle. So what would we write? Chelsea, yeah. There we go. Yeah. Y squared plus X squared equals Z squared. Again, just kind of pulling out those parts for the legs, for the hypotenuses. So let's go, what'd you say, Y squared plus X squared equals Z squared. Good. Again, that would be kind of under the same step, right? I just used the Pythagorean theorem here. All right. We're going to get a little bit different here. So I'm going to kind of lead you through this. We have that XY, segment XY and segment AB, they're the same length, right? So is Z going to be equal to C? Are those numbers going to be the same? Yeah, they're the same length. They're congruent, right? So if these guys are the exact same, I should be able to kind of use substitution here. Doesn't matter if I say A squared plus B squared equals Z squared, or if I say Y squared plus X squared equals C squared, C as in cookie, right? If they're the same number, I should just be able to substitute them out anywhere. So that's kind of what I'm going to do. Off to the side, I'm going to say, well, C is equal to Z. So let's just substitute it in one of our equations. Let's just take, I'm going to take this Z, and I'm going to plug it in right there for C. And I'm going to come up with a new equation. It's the same thing, because again, C and Z are the exact same thing. But now I can say that A squared plus B squared equals Z squared. That feel all right? Okay. It's kind of cool. It's going to work out and it's going to be really awesome. I love this proof. Okay, is Z squared equal to anything else? Is that equal to anything else? What do we think? I mean, I see it right here, right? It's got to be equal to the y squared plus the x squared. So I'm just going to kind of, again, make a little bit longer equation and say, well, z squared, it's also equal to, let's just rewrite this, right? It's also equal to x squared plus y squared. Okay, and we're going to do another substitution thing here. Kind of like what we said earlier, C and Z have to be the same. Well, we know that segment AB and segment XZ, those are congruent, so should B be equal to Y? I mean, if they're congruent segments, their lengths are congruent, right? So let's kind of do the same thing like we did over here. Well, B has to be equal to Y if these are congruent segments. Elijah, thank you. Good, good. And let's kind of do another substitution here, right? Let's see. So if B is equal to Y, I'm just going to let's take Y again and just substitute it in right here where I see B. Why not? So that would be A squared plus Y squared. Again, we're just substituting values that we know are equal. Equals. And I could rewrite all this, but let's kind of drop this middle connecting Z squared. Let's just say that A squared plus Y squared is equal to X squared plus Y squared. Is that okay? All right. We're getting somewhere. It may not look like it, but we're getting somewhere. Okay. Now, looking right here at this equation, is there anything that you can cancel? Anything that's the same on both sides? Yeah, the y squared. Good. I mean, it's the same on both sides, right? It's going to cancel. You could try and subtract y squared from both sides. They're just going to cancel each other out. All right. So that kind of leaves us with a squared equals x squared. That's a true statement, right? Okay, well, if a squared equals x squared, if these square numbers equal each other, then like the bases should be equal too, right? A should just be equal to x. We okay with that? There we go. A equals x. And you could like square root both sides. The squares would cancel. Again, you're going to get that A equals x. And hey, what does that tell us? A is a segment length here, and x is another segment length. So would those two segments be congruent now? Yeah. So I'm going to go add into my picture. Well, segment CB has to be congruent to segment ZY. Again, we're just kind of pulling this from the algebra that we just did. So can we now use another triangle congruence to show that these two triangles are congruent? Other than HL, because that's what we're trying to prove. What do we think? Are these congruent by what theorem? Again, no, because we don't have two angles. It could be side, 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 right? I mean, now we found that third side. We have all of our sides congruent. It could even be SAS, right? Side, angle, side. So I'm just going to say side, side, side for now. And we've just proven HL, right? Thumbs up. I mean, that was kind of a lot. It was kind of cool. It works out. We all right with that? Okay. And you can even see like the steps if you were to do a statements and reasoning proof, right? Pythagorean theorem, substitution, maybe a little bit of transitive property here, right? Again, another substitution, maybe like subtraction, property of equality. Okay. Let's see, what is next? You guys look so excited, so we're going to do one more proof. One more proof. And then I'll give you some homework and we can have some homework time, okay? So one more proof here. Again, we want to prove that these triangles are congruent. Give yourself a little sketch maybe. We got triangle RST, triangle UVT. Thank you guys for hanging out at home. Are we doing okay as well at home? You can give me a yippee in the chat or keyboard smash. Kanan, yes, good, good. Awesome, Anna Karen. All right. I'm going to go ahead with some statements and reasoning. All right. Hey, well, step one, what do we know? What's something we know? What's given to us? Even from the picture, maybe. Thank you, thank you. Angle S congruent to angle V. One other thing. I know you guys probably know it, right? We're just too afraid to say it. Yeah, I think we said something about R and T's and V's in there, right? We got that segment RT and TU, right? Segment RT congruent to UT. There we go. Given. Okay. They're not right triangles, so we're not going to use HL here. I don't know anything about maybe a segment bisector or anything about a midpoint, so I'm probably going to throw out side angle side, right? Can we find another pair of angles here? Angle R and angle U. Again, I don't know if these are parallel lines, so I don't know if we could use any. If we knew that these two were parallel lines, then we could say something about alternate interior angles. What about something here, though? There we go, yeah. Keyword vertical angles, right? These are directly across from each other. They're vertical angles. We know that they're congruent. So I'll go add that onto my picture. And RTS congruent to UTV. Again, those are just vertical angles. Okay, now from here, what does that look like? Is that going to be a triangle congruence theorem? What's the one we wrote down yesterday? There we go. Angle, angle, side. We okay with that? Again, we have that side. It's considered non-included. It's not in between these two angles. Angle, angle, side. Angle, angle, and then side. So there we go. I'm going to restate what we wanted to prove. Triangle RST congruent to triangle UVT. Again, angle, angle, side. Not too bad. Not too bad. Okay. Thank you for hanging in there with me. Feeling a little bit more prepared with angle, angle, side, and HL? Maybe? We're getting there. That's what I like to hear. Well, we'll have some practice with the homework here. I'm going to give that real quick. Let's see. So it is section 8.4. It's on page 248. Numbers 1, 5 through 12, and 15. All right. Again, some of these ones between 5 and 12, they're going to give you like a picture. You know, they may give you something that looks like this and explain how you know they're congruent. You don't have to do a full proof, but talk about some vertical angles. Talk about maybe the reflexive property if you have two triangles that are sharing a side, right? Don't just say, yeah, they look the same. Yeah, I think so. All right. Make sure you can justify your answer. Provide a little bit of reasoning. If it asks for you to do a proof, you know, please do it. You call a proof. Okay. People at home, let me get my notes page and then I will. All right. If you are at home, feel free to hold up your notes so I can get those checked off. I'll stop recording. I'll post that recording later in case